Okay, so this is dividing radicals, which will use the multiplying and simplifying, all the things we've done so far this chapter. So the first part of dividing radicals is break apart the radicands and using the quotient rule. Remember, the radicands are the things inside the radical. So in this case, I have square root of a over b. Well, that's the same thing as saying square root of a over square root of b. Okay, you separate it out into two different radicals. Okay, we look for any perfect squares and simplify things. Simplify, divide, reduce the radicands if possible, and simplify. I know that sounds like a lot. So let's just come down here and I'll just give you an example here. I'm actually going to save number 1 for you because it's a little easier than some of these others. So, so let's start with number 2. So if I separate this out, I end up with square root of 8 over square root of 32. Whoa, it didn't write. There it goes. Okay, so what we're going to do is simplify each of those radicals. So I'm going to come over here to the side. I'm going to say, okay, square root of 8, and I have a square root of 32. And I want to simplify these. Let me move over here. So I'm going to take out a prime number. Smallest prime number that goes into 8 is 2. Well, 2 times 4 is 8. But 4 is not prime, so I need to take prime number out of 4. So 2 goes into 4 2 times, and that 2 is prime. So now I have the prime numbers that multiply together to be 8. This is a square root, so if we circle any pairs, so here's a pair of 2's. And then this 2 here didn't have a buddy. So we'll rewrite square root of 8 here in just a minute. Let's go ahead and simplify square root of 32. It's even, so you know 2 goes into it 16 times. 16 is not prime, so we're going to take 2 out of that. 2 times 8 is 16. 8's not prime, but 2 goes into 8 4 times. 4 is not prime, so 2 goes into 4 2 times. All right. Now I have all prime numbers that multiply together to be 32. Circle pairs. So here's a pair. Here's a pair. And then we have this 2 that didn't have a buddy. So what we can do now is rewrite these two radicals. Okay, so we're going to rewrite our radicals. So square root of 8 simplified. On the outside, I have a 2. Inside, I have square root of 2. That's a square root. It's not showing up with this thing. Sorry about that. And then square root of 32, I circled 2 pairs of 2's. So you multiply those together, and I get 4. And you had inside that 2 that didn't have a buddy, so you get square root of 2. And then we're going to simplify. So square root of 2 divided by square root of 2 is 1. So these cancel out. And then I have 2 over 4, which simplifies to a 1/2. That's so much. That looks more right then. Okay. A lot easier than looking at this radical like that. All right. So let's go down to another problem here. Let's do number 5. Okay, so let's come over here and do number 5. All right, so it's already separated in 2 different radicals. So we just want to simplify square root of 10 and square root of 45. This time I'm going to kind of do it over here. Square root of 10. Okay, it's even, so 2 goes into it 5 times. Notice those are both prime. So square root of 10 doesn't simplify. So when I rewrite it, I, no matter what, have square root of 10 on the top. Okay? So let's do square root of 45. So I have square root of 45. Okay? It's not even, so 2 doesn't go into it. So you just need to pick another prime number that does. I can't help you. 5 goes into it 9 times because it ends in 5. So that's the easiest to look into. Then we have 9, and 3 and 3 multiply to 9. And now I have all prime numbers. They multiply together to be 45. Circle any pairs. So here's a pair. This 5 doesn't have a buddy, so he's not getting paired up. So when I write this square root of 45, outside, because I circled 3's, I have a 3. Inside, I have a square root of 5. Okay? Now, I did show you that square root of 10 can't simplify. Okay, so square root of 10, actually, I showed you was 2 times 5, and you can separate those out into two different radicals. And we have 3 square root of 5 on the bottom. So these square root of 5s actually, square root of 5 over square root of 5 is 1, so they cancel out. And that just leaves you with square root of 2 over 3. Okay? All right, so let's see. I want to find one. I think all of these are going to simplify pretty well the same. So let's come over. Let's do one more that has a number on the outside. So let's just do one of these bottom ones. Let's go all the way to number 12. Okay. All right, so we need to simplify square root of 84. And square root of 7 doesn't simplify, but let's do 84 here. Okay, 2 goes into 84 42 times. 42 is not prime. Okay, so 2 goes into that 21 times. 21 is not prime, but that is 3 times 7, and those are both prime. So I can circle a pair of 2's, and then this 3 and 7 don't have buddies, so I'd multiply them back together, and they go inside my radical. So when I write this top, my numerator here, I still had this 3 out front. We can't forget about that. So I have 3 times, and then I circled a 2, so that 2 goes on the outside. Inside my radical is that 3 times 7 down here, so that'd be 21. Okay, and I'm going to go ahead and simplify that more. 3 times 2 is 6, square root of 21. Okay, now the denominator here, I can just carry it through. 15 over square root of 7. 15 over square root of 7. Okay. That square root of 21, look down here. It had a 7 in it. So let's just go ahead and replace that back with square root of 3, square root of 7. So then these 7, square root of 7 over square root of 7 is 1, and they cancel out. It leaves me with a 6 square root of 3 over 15. So my radicals are now all simplified, but I have a 6 over 15. So we need to find a number that can go into both of those. Well, they're both divisible by 3. So if I divide 6 by 3, I get 2. Still have the square root of 3. Divide 15 by 3, and you get 5. So this is number 12, simplified. None of these answers should end up with a radical in the denominator, okay? All right, so your job today is to do the rest of these problems. Okay, I already circled number 1, so you're going to do 1, 3, 4, 6, 7, 8, 9, 10, and 11, and then have them checked.